Today we are going to discuss about the term which is so called mean terms. So in mean terms, its complement, let's take complement of a, which is represented by a bar or a prime, is we consider it as a 0, and a is considered as 1. So in mean terms, if each term in sum product or SOP form contains all the variables, then the expression is known as standard SOP. So what are they? Okay, let's take an example. Suppose we are having three variables a, b, and c. Okay, and in decimal system, let's take we are having a number 0. So 0 uh, in binary system. So let's take these are binary systems having 3 digits, also called bits. Okay, so 0 in decimal system is equivalent to 0 0 and 0. 1 is in which is equivalent to 0 0 1 in binaries. So these are binaries. Okay, so 2 is 0 1 0. Okay, you might be thinking how easy or how one can say that 2 is equivalent to 1 and 0. I'm not going to calculation part. Okay, so let's take you can use your calculator, scientific calculator, in order to find the same. Okay, so I have already uploaded these things in. Okay, let me explain you. So press the mode button twice, then you can get the base. So for the base you have to press 3 to select it. Now I have written here in decimal 2, decimal 2 is equivalent to 1, I mean 1 0 or 0 1 0 in if we are considering it at 3 digits or 3 bytes. Okay, so what is the number 2 is equivalent to 1 0? Let's see how. So if I press 2 here, okay, it is pressed here, you can see. Then I pressed OK button, then it is showing here 2 is in the 2 number I type here, it is stored in S decimal, but we are concerned in binaries. So you can see here, okay, in it is written here bin. You can see the log button here above it can be seen it is bin is written there. So you have to just press 1 and you can see it is 10 is written, and here you can get you can see care you can see here it is b, that is for the number 2 in decimal is equivalent to 10 in binaries. Okay, uh, so 2. So what about 3? Have a look. So if I press 3 here, okay, first I have to, okay, now it is d, that is the 3, the number 3 in decimal, it is stored in decimal. So what about 3 in binaries? So you have to just press binary and you can see it is 1 1. So this way you can find all the numbers in one to another form. Okay, so what about 4? For 4 it is 1 0 0 1 0 0, and for 5 it is 1 0 1. For 6 it is 1 1 0, and for 7 it is 1 1 1, and for 7. Okay, so we are now what about mean terms? Okay, so mean terms. Okay, mean terms, as it is already, I have already said earlier, for 0 uh, complement uh, a bar or a prime means 0. So here a is 0, b is 0 and c is 0. So in mean terms we will represent this as a prime, b prime, c prime. Okay, and for this, for the second row here, we will a, b and c, because a it is 0, so we will a prime, then b prime, and here c we are having 1, so c. So in this fashion we will write all the numbers here. Let me write. So it is written here, you can see, you can verify one another every term here, like it is a VC written here, that is a is 1, b 1 and c 1. So this, all right, so these are mean terms. Okay, so these are mean terms. So in short, we cannot always write these numbers. It is very tedious and time consuming process. So we use, or we denote this thing, these numbers in m, small m, with subscript 0, 1 2 3, and in this way we have 7 at the end here. So this is the mean terms. What about max terms? So max terms, so uh, in max terms, which is denoted by m, capital M, and here uh, mm, here the complement, that is a bar, is written as 1, and the number a is written as a 0. So that's the representation of max term. We will discuss more about max terms in another